trigonometrical functions, and one of the most important and first and foremost questions that they would normally ask a learner is to identify or find the period. So usually the period, if you are given a function f of x is equal to 2 sine 3x plus 4. Now this is a trigonometrical function, and if you are looking at it, it has got certain properties that will allow you to find certain things, and for you to be able to identify the period from the function, you need to just look at the function in its totality. And in this case, when we are looking at the function, we look at the number that is directly before the angle, and that is the number that is directly before our angle, and that number is 3. Now this number is related to the period. In other words, if you want to find the period of this graph, you would know that this number is telling you that 3 graphs equal to 360 degrees. In other words, 3 graphs are occupying the space which is a full revolution of 360. So if I want to know what one graph will occupy, one graph will give us 360 divided by the 3, and that one graph will occupy 120 degrees on the Cartesian plane. Now if you now look at that, this number then becomes the period. Period is for one graph. In this case, it's going to be equal to 120 degrees. Let's try another example. Now, suppose that we have got f of x is equal to cos 1 over 2x plus 2. Now, again, we are saying this number here is supposed to help us to find the period. So in this case, it's going to be half a graph will give us 360. Always that number tells you how many graphs will give you 360. So if I want to get a full graph, that means these two will come and multiply. So one graph, the 2 will come and multiply. There will be 2 times 360. So, and then this will give us 720. So this is telling us how to find the period in the simplest way. Again, let's look at another example. I'm trying to use a lot of examples so that some people can see. F of x is equal to sine again, and in this case now I'm going to use 4x. We look at that number again, the number just before the angle is 4. So here we're going to say, oh, in this case 4 graphs equal to 360. So if I want the period is one graph will be 360 divided by 4, and this will give us 90. So that's the easiest way of finding period from the equation. You look at the number that is directly that is associated with the angle. Now, what about if we are now asked to find the period not from the equation but from the graph? So if we are asked to find the period from the graph, So let's look at the period from the graph, and I'm going to just draw a graph. Let's say you've got this graph, for instance. Now, and then obviously they will give you a numbers. So in here I'm going to put 90 just for sort again. Now, if we are looking at this, the best way to look at it is to find out how many quarters of the graph we have. So normally I use quarters because quarters are you can easily find out the distance occupied by one quarter in terms of the period occupied by the number of the angles occupied by one quarter. So I'm going to divide my graph into quarters. So there is 1 quarter. There is another quarter. I'm using the red to shade, and then we will look at how many quarters there are, and then obviously now I'll use a different color for the other quarters there. So you see. When I'm looking at this graph, I can see how many quarters. I can see the first one. This is quarter number 1. That is quarter number 1. That is quarter number 2. Quarter number 3. Quarter number 4. Quarter number 5. Quarter number 6. Now, there are 6 quarters there. So, all these quarters are occupying a distance of how many? 90. So, I will say, okay, fine. There are 6 quarters occupying 90. So, I will say, okay, fine. 90 divided by 6. Okay? That will give me the distance occupied by each quarter. This will give me 15. So each quarter is occupying a distance of 15. So in other words, this quarter is occupying this distance here is actually just 15. Now, if I want to find out what a full circle or what a full revolution will be, I would then say, if I have got 1 quarter, 1 quarter graph is equal to 90 divided by 60 is equal to 15. Then 4 quarters is equal to 15 times 4. So in other words, 4 quarters will give us for the full period, which is in this case going to be 60. So the period of this graph is actually 60. In other words, by the time we move from here, that's 15 plus 15 plus 15, that's 45, plus 15. Now we've got a full revolution. So in other words, if you are looking at this graph from another angle, let's look at it from another angle. So you take this quarter here plus this quarter here, you get this type of shape, isn't it? Then if you take this quarter there and this quarter there, you get the bottom part to make a full circle. So that's how that graph will look, and you can see now, if I am going to shade it, it will have that one, and obviously this side. So you see, you now have a full circle, which is a full revolution. So that is how we look at the period. Let's look at another graph. Let's look at another graph that some people can understand. Now I'm just going to draw. You only look at the section of the graph where enough information is provided. So suppose, say, someone was to draw a graph like this. Now, this is a tree graph, and it obviously is going to start from 0, but you know that it's running from 0 to 180. But if you look at this graph, it is divided. It is comprised of where this graph is comprised of quarters, and in this case we've got this quarter here plus this quarter here, so there are actually 2 quarters. So if I want to work it out, I'm going to say, okay, fine, let me work this one out quite nicely. 2 quarters is equal to 180. Sorry, let me just write it properly. 2 quarters of a graph occupies 180 degrees. So now I want to find out how much one graph occupies. So for me to find out how much one graph occupies, I'm going to divide this one by 2 quarter, and also divide this one by 2 quarter. That's another way of doing it. So if I divide that one by 2 quarters, it means that I am going to get 180 divided by 2, that's 90 times 4, and then that's going to be just a simple 360 degrees. So from the graph, you are taking the distance that each graph. Let's look at another example so that we can best understand period. I'm now going to draw another graph, and I love drawing this graph because it's just beautiful, and I'm going to put 1000 there. And that's a big number. For some people, they're used to working with small numbers, and you're looking at this graph, so you're saying to yourself, okay, if I look at this graph, it has got how many quarters? It has got 2 quarters. It has got this one, it has got this one. Can you see? So there are actually 2 quarters, and I'm shading them with different lines because I don't want to use a different color. I'm just using 2 quarters there. So in this case, we now have 2 quarters, 2 quarters again, 2 quarters of a graph, giving us 1000. So if I want to find out what one graph occupies, I divide this one by 2 quarters, and I divide this one by 2 quarters, and this will give me 500 times 4, that's 2000. Can you see? 2000 degrees. So in other words, if you wanted to know the period of a graph, all you have to do is to look at it in quarters. Trying to look at it in terms of whole graphs can be a bit difficult, because you might not be able to see the whole graph, and they might only be able to provide you with a portion of the graph. So normally I use quarters because quarters, they will make sure that you can achieve your objective. So that's how we find the period of a graph.